Good morning, children. This is Shubhal sir speaking. In the previous video, we had a discussion on a few concepts about understanding quadrilaterals. We discussed about how quadrilaterals are different from other polygons, what are the basic properties of polygons and all. What is quadrilateral, what are the types of quadrilaterals, and how to find the measure of the sum of all interior angles. We had a discussion before. So children, in this particular video we are going to discuss about more things about regular polygons, as we have as I have explained about what are the types of polygons and all. There are basically two types of polygons: regular polygons and irregular polygons. Now the question arises that, so what is a regular polygon? Regular polygons are the polygons in which the measure of all the sides and all the interior angles are equal. I'm repeating my word once again. The polygon in which all the measure of all the sides of polygon. Suppose a polygon in which the measure of one side is 5 centimeter. So naturally all other sides, all the existing sides are of 5 centimeter. And for an example, if the measure of one angle is 30 degree, the measure of one angle is 30 degrees, so all other angles, all the interior angles are measuring 30 degree. So in that case, that particular polygon will be known as regular polygon. So here in this particular video, children, we are going to discuss about the regular polygon. So what is regular polygon? Regular polygon, with examples I'm giving. Suppose an equilateral triangle in which the measure of all three sides are equal and measure of all three angles are equal is known as equilateral triangle, and that is an example of a regular triangle or regular polygon. A polygon with three sides, a regular polygon with three sides is known as equilateral triangle. Equilateral triangle. Now here is what, let me draw one hexagon for you all, in which this is a regular hexagon. Regular hexagon means in which the sides, the measure of sides 1, 2, 3, 4, 5, 6, the measure of all six sides are equal, and all these six angles are of equal measures 1, 2, 3, 4, 5, 6. This is an example of regular polygon. A regular polygon with six sides is called hexagon. Regular hexagon 1, 2, 3, 4, 5, 6. In this particular figure, as we can see, there are six sides and six angles, six interior angles. So this is an example of a regular hexagon. So children, if a polygon with five sides, equal five sides and equal five angles. So what is the name of that particular regular polygon? That is an example of regular pentagon. The regular pentagon looks like this. Regular polygon 1, 2, 3, 4, 5, in which all five angles 1, 2, 3, 4, 5, all these five angles are of equal measures. They're measuring equal, and they're measuring equal, and they are having equal five sides. So all five sides are of equal measures and all five angles are of equal measures. So this is an example of a regular pentagon. Okay, children. So now question is that if a pentagon is not regular, how it could be look like? It could be look like 1, 2, 3, 4, 5. Any shape, in which might be the sides are not equal, might be their measure of their angles are not equal. So that would be considered as a normal pentagon. Any figure having five sides is called pentagon. But if the figure has got all five sides are equal in measure, all five angles are equal in measure, so that is an example of a regular pentagon. So children, here as we can see, I wrote some questions over here. What is a regular polygon of three sides? A regular polygon of three sides is a equilateral triangle. A regular polygon of four sides in which all four sides and all four angles are equal. So children, out of all these quadrilaterals, all the quadrilaterals like rectangle, square, rhombus, kite, trapezium, all these quadrilaterals, among all these quadrilaterals only square has got four sides are of equal measures and four angles are of equal measures. So naturally only quadrilateral which is a regular polygon, that is square, five sides. Just now as I have explained, a regular polygon of five sides, five sides of equal measures and five angles are of equal measures, that is a regular pentagon. That is a regular pentagon. So children, as I have explained in the previous video how to find the sum of all the interior angles. Suppose you have got a pentagon and you have to find the sum of all these angles of a pentagon. The formula is, as I have explained it before, number of sides minus 2 into 180. So if I want to find the measure of sum of all the angles of a pentagon, I have to go through with this particular formula. The formula is number of sides, matlab 5 minus 2 into 180 degree. 180 5 as this is a number of sides minus 2 into 180. That is an example. So here children, in question number 6 there are some figures and you have to find the measure of this unknown angles. The angles which are not mentioned, you have to find this. The very first thing is what to identify the figure belongs to which category, like whether it's a triangle or a quadrilateral, a pentagon, a hexagon. What is that? That needs to be found first. And we have got the formula. The formula is number of sides minus 2 into 180. By using this particular formula, we can find the measure of all these unknown interior angles. Let's have a look. Here is the figure. One angle is 50 degree, one angle is 130 degree, one angle is 120, one angle is x. I have to find the measure of x. The very first thing is to identify which figure is this. 1, 2, 3, 4. There are four sides. Means this is a quadrilateral. Okay. As we know, the sum of all the angles of a quadrilateral is 360 degree. We have been learning this right from class 6. That the measure of all four angles of sum of all four angles of a quadrilateral is 360 degree. So one angle is x. Out of four angles, three angles are mentioned. How to find? We can go through linear equation process or we can simply find. It's completely pure. Add these three angles and subtract it from 360. You will get the measure of x. I'm repeating my word once again. Add all these three angles and subtract it from 360 degree. You will get the measure of x. Next one. Next figure is one angle is given outside which is 90 degree. So it means that this particular side is perpendicular. No problem. If outside is 90, of course inside the interior angle will also be 90. Because it's on a straight line. This particular side is lying perpendicular on this particular base. So if the measure of this angle is 90 degrees, of course this angle is going to be measured 90 because they are perpendicular. Alright, and they are supplementary of each other. Alright, so one angle is 70, one angle is 60, one angle is 90. The measure of x is, add these three angles 70, 60 and 90 and subtract it from 360. You will get the measure of x. You will get the measure of x. Now in this particular figure, one is 30, one is x, one is x. This is 70 and this is 60. 1, 2, 3, 4, 5. Children, the very first thing that we have to understand, it's a pentagon. It's a pentagon. Okay, no problem. So here, as exterior angle is 70 and it's lying on a straight line, so inside angle will be surely How much, children? This is 110 because they are forming a linear pair. Outside exterior angle is 70, inside angle will be 110. Outside angle is 60 here, interior angle will be 120. Now, question is that, sir, we got the measure of 1, 2, 3, 3 angles. Out of 5 angles, we got the measure of 3 angles. Then how to find the value of x? In this particular question, the very first thing we have to understand what is the measure of sum of all the interior angles. As it's a pentagon. As it's a pentagon, we have to find the measure of sum of all these angles, all these interior angles. Simply go for formula. The formula is number of side, matlab 5 minus 2 into 180. Children, I am using a formula in order to find sum of all the interior angles of this particular figure. So here the formula is number of sides minus 2 into 180. Number of sides is 5 minus 2 into 180. 5 minus 2 is 3 into 180, 0. 540 degree. 540 degree is the sum of all 5 angles. Now the process is we can simply write x plus 30 plus 120 plus 110 is equal to 540 degree. Children, why did I write this? Because I have to find the value of x. So according to the question, sum of all the interior angles like x plus 30 plus 120 plus 110 should be 540 degree. From where I got this 540? I got this from the formula I have used in order to find the sum of all the interior angles. So if I get the value of x from here, that is only my answer. So children, this way we deal with such questions. So I believe that you are going to try this out your own, and you will be dropping me your queries if you are facing any problem to understand. And in exercise 3.2, there is a exterior angles property. Exterior angle property. Children, you might be having many figures in which you have to find the measure of exterior angle of a figure, whether it's a regular figure. For this regular polygon, the formula is the formula is 360 degree divided by number of sides. If you divide 360 degree by the number of sides of that particular polygon, you are going to get the measure of exterior angle, each exterior angle. You are going to get the measure of each exterior angle. The formula is 360 divided by number of sides is equal to the measure of each exterior angle. This is how we can find the value of exterior angle. So children, I believe that you will be trying out this particular formula. And here is one thing that I want to say. From where we got this 360 in the formula? This 360 has come from a process or a technique or a rule, whatever. When we are going to form a polygon, it tends to be a circle. When circle is, we are using sides. We are drawing the sides. We are forming a polygon. After a certain time, as the number of sides increases, it becomes, or it tends to be more like to a circle, because the circle measures 360 degree. As a circle measures 360 degree, so the angle of a circle is 360 degree. So as the number of sides of a polygon increases, of a regular polygon increases, it tends to be more similar to a circle. That's why we got that 360 degree from there. So children, I believe that you are going to try out all this, and today I'll be expecting the copy submissions. Those who have submitted, well done, very good, as I've seen, and those who haven't, I'll be expecting this from you all today. Thank you so much. Thank you children. Have a good day.